Hello learners, today we are going to talk about the origin of ocean basins. Now, in trying to describe the origin of ocean basins, we have to describe the origin of the entire uh, bigger surfaces of the earth, the land surfaces and the water surfaces. So, let us try to understand how the ocean basins came into being. So, in the previous unit, there was an introduction to the subject of oceanography, and now you are acquainted with the definition and scope of oceanography. You are also aware of the historical development of the subject through different oceanic expeditions. One of the earliest, of course, was by Captain Cook, where he drew the oceanic outline of the Pacific. And in this unit, you will study the different theories related to the origin of oceans in particular. As I should reiterate once more that when we are talking about origin of oceans, we have to talk about origin of oceans in conjunction with the origin of land surfaces, other land surfaces. To understand the origin of oceans, it is also important to examine the different theories which explain the origin of the earth as well as the major relief features on the earth's surface. The major theories that have been postulated by scientists in the historical context are the nebular hypothesis, the planetesimal hypothesis, the tetrahedral hypothesis, the continental drift theory, and the concept of isostasy. Some of these theories have been considered redundant in the perspective of newer scientific findings, but all of them have helped in understanding the newer concepts, because we have to build the newer concepts basing on the older concepts. Why do we have to negate some of them? What are the problems with those particular theories are very important. So that those are the stepping stones or the building blocks of coming to the newer theories. So it is really important, one needs to understand and critically evaluate each of these theories. So first we talk about the nebular hypothesis. The Prussian philosopher Immanuel Kant was one of the first to put forward a theory regarding the formulation of the universe. In this, he also considered Sir Isaac Newton's law of gravitation. According to him, the collision of the hard particles of primordial matter that existed in original form in space generated heat and began to rotate as they fell upon one another due to mutual gravitational attraction. The original cold and motionless cloud of matter became a vast hot nebula spinning very rapidly, and rings of matter were thrown out one after the other to form its equatorial area by centrifugal force. The matter remained as an incandescent gaseous mass, which we call the sun. Each ring of matter thrown off by the centrifugal action became an individual planet, each of which threw off some matter to form their respective satellites or moons. In this process, the entire solar system was created. There are, or one should say, there were fundamental problems of Kant's hypothesis. Basically, because of his postulate that the rotation set up by the collision of primordial matter with each other contradicts the principle of conservation of angular momentum. That is, interactions between different parts of a system will not change its total amount of rotation, which remains constant. But the importance of the theory lies in the fact that this was a theory which preceded Laplace's famous nebular hypothesis theory of 1796. This theory was one of the dominant cosmological theories for a long time. Here we see in the inner hotter part of the solar nebula, planetesimals were composed mostly of silicates and metals. This hot, rocky material near the center of the solar system gave rise to terrestrial planets with metal cores mostly composed of iron and nickel, Mercury, Venus, Earth, and Mars. So, we know from the interior of the Earth that these metals, which are iron and nickel, are there at the center of the Earth, which is the core of the Earth. In the outer cooler portion of the nebula, water ice was the dominant component. This gave rise to the gas and ice giants Saturn, Jupiter, Neptune, and Uranus. Rocks that escaped the pull of planets were left as asteroids scattered through the solar system. Many of these rocks orbit the Sun in an area between Mars and Jupiter known as the asteroid belt. Then we come to the nebular hypothesis by Laplace. According to Laplace, the primordial matter in space was already a hot and rotating gaseous nebula. This rotating hot nebula was cooling, leading to contraction, and a result, there was increased rotation. This would also result in an increase in centrifugal force, which would at a time strike a balance with gravity at the equator of the rotating body. At this stage, the ring of material thrown off would be weightless and eventually move away from the original body and aggregate to form a planet or a satellite of the main body. More and more planets and satellites would form in this way. The initial residual mass would remain as the Sun. In this, he is agreeing with Immanuel Kant that the residual mass will remain as the incandescent body, which is the Sun, gaseous incandescent body, which is the Sun. This was a simpler hypothesis and explained that each of the planets and satellites had motions of rotation and revolution in the same sense, and that orbits of several planets were on the same plane. The nebular hypothesis implied that all planets pass through gaseous, then cooled to a liquid stage, and ultimately developed a solid crust. This concept tallied with the knowledge that temperatures increase with depth below the solid crust and also that of volcanic activities. As a critique of this concept, subsequent theorists mentioned a solid beginning of the Earth's crust, as there was no evidence of any significant tidal episodes in its body, which should have been on a liquid Earth. But later, cosmologists endorsed the molten stage in the Earth's history. This idea has been corroborated by later theorists. So, the nebular hypothesis became a major stepping stone for the development of other theories. That does not mean that Kant's theory was totally negated, but all these sort of built up to a level on which the newer theories were added on. According to the scientists who tried to understand Laplace's ideas of nebular hypothesis, the materials forming the atmosphere, the oceans and the solid lithosphere itself were all formed from the aggregation of planetesimals. It has been suggested that the primary bulges and depressions in the lithosphere were due to initial distribution of atmospheric pressure. The initial gaseous matter, as it cooled down, gave out the volatile gases and created the first atmosphere, which had pressure differences. The semi-solid cooling lithosphere reacted to the pressure differences and created the depressions and bulges. Some other theorists believed that the unequal distribution of the aggregating planetesimals created depression and bulges, the bulges being the continental areas or the land areas, and the depressions, when filled with water, became the oceans. In its early form, as postulated by Laplace, the nebular hypothesis has not been regarded as a possibility of the formation of the universe. He or his followers did not show how the rotating rings of matter coalesced into spherical planets. Rather, the theory would indicate that the rings of matter would break up into many nearly equal balls of matter in the same orbit. The nebular hypothesis enjoyed popularity for a long time in spite of its inadequacies, and several variations and modifications were proposed by subsequent geoscientists. Now, why this enjoyed popularity was that there was no subsequent or consequent theories which were built up at this particular time, and to the scientific community this seemed a very plausible way of the built up of all their planets and their irregular surfaces. The bulges were the oceanic, the continental surfaces, and the depressions were the when filled with water would be the oceans. Then we come to the another theory, the planetesimal hypothesis. The planetesimal hypothesis was proposed in 1905 by Thomas Crowder Chamberlain, who was a geologist, and Forrest Ray Moulton, who was an astronomer, to explain the formation of planets. This was an inclusive theory about the formation of the universe. The theorists do not regard the formation of the planets from primordial matter, which in the process of evolution created the sun as the central mass. Once more, as we've seen discussed in the other theories, that the sun was at the center, and while the other theorists, Laplace or Kant, they understood that the sun was the remnant of all the primordial matter and the planetesimals. But here, in the process of evolution, the sun was created. This was Chamberlain and Moulton's concept. This theory suggested that the planets formed from small solid bodies called planetesimals. Once more, the term planetesimals are coming in. Small, hard, rocky primordial bodies in space, which were aggregating to form planets. The planets were thought to be biparental in origin as a result of interaction between the sun and another star of comparable mass. There were a severe tidal distortion caused by the passing star, together with the eruptive tendencies of the matter in the sun itself. Here we see that there is material from the sun which continuously goes into space. If you look at any of these AI images of the sun, then you can see that this orange mass is constantly, when we have drawn the sun as a child, there were these portions which surrounds the circle, which are the eruption from the sun itself. So it is something which has been corroborated by all scholars. So it was postulated that a tidal disruption led to the ejections of small portions of solar matter to considerable distances, the passing star pulling them towards the line of its own motion. With the ejected matter, larger nuclei congregated together, then in turn collected the smaller scattered bodies or planetesimals, which eventually became the main planets of the system. So it was the planets were biparental in origin. One is the sun and the other is the passing star. Both has their own gravitational pull. There are material which is being ejected from the sun because its constant motion in space, and the passing star would bring out those material from the sun and in that way and which solidify to form the planets. Here we can see an example of the planetesimal hypothesis proposed by Moulton and Chamberlain in 1900-1905. The theory was widely accepted 35 years before being chucked or debunked. This theory did not mention that the Earth was at any time at a molten condition. Rather, it grew from aggregation of planetesimals rapidly at the beginning, but with decreasing speed. Internal heat was created by the process of condensation in the matter during its process of growth. Some of the molten material in pockets, because of its constitution, rose towards the surface where it cooled, leading to a solid stony crust and a metallic material underneath it. The planetesimal hypothesis, like its preceding theory, had its own group of dissidents. There were many reasons to critique this theory, but its basic principle has been accepted and built upon. Then we come to another group of theories, or one would say one major theory, the tetrahedral hypothesis. This hypothesis is not building on the planetesimals or the asteroids or primordial matter which are coming together to form the different planets, but this is trying to understand the shape of the Earth itself. The tetrahedral hypothesis was postulated by Lothian Green in 1875. So, according to him, there was a tetrahedral arrangement of land and water distribution on the Earth itself. Now, this is a change because the three other theories that we have come across before was talking about how the universe that we see, that the solar system was built, the sun at the center and all the planets with its own satellites or moons surrounding the sun. But in the tetrahedral hypothesis, Lothian Green is trying to understand or trying to come to some conclusion about the shape of the Earth itself. So, according to him, there was a tetrahedral arrangement of land and water distribution on the Earth. You can just refer to the figure in 2.1 to understand this. The tetrahedral in this case would be standing on one point. The four flat faces of the tetrahedron represented the four oceans. The flat upper surface would be the Arctic Ocean, circled by land around it, land representing the northern regions of Eurasia and North America. The three flat vertical sides represented the Pacific Ocean, Atlantic Ocean and the Indian Ocean. The vertical edges corresponded with the north-south landmasses, the Americas, Europe, which was separate from Asia at that time, and then of course Asia. The lowest point was the continent of Antarctica. Here we have the tetrahedral Earth, figure 2.1, the arrangement of land and sea on a tetrahedron. Very, very simplistic kind of a diagram, but Lothian Green saw that from globes that this was the arrangement of land and sea on the Earth. He is not trying to explain the how oceans, how the land continents were born. He is trying to understand and trying to justify that the shape of the Earth itself. Gregory looked at Green's hypothesis and came to certain conclusions. He pointed out that there were certainly reasons to support the theory, as there was more land in the northern hemisphere than in the south. We know that the southern hemisphere is often called the water hemisphere or ocean hemisphere, and the northern hemisphere is land hemisphere. The continents tapered towards the south and the ocean tapered towards the north. Also that the land tri-radiated from the poles. The oceans and the masses and land masses were antipodal to each other, just opposite each other. All this roughly corresponds to a tetrahedral form. This theory can also be based on the fact that the sphere whose surface was the smallest in relation to its volume can collapse to a tetrahedron which was the largest surface as in relation to its volume. It's just a geometric concept which tries to explain how a sphere is collapsing to form a tetrahedron which has the larger surface area in relation to its volume. Now, a lot of experiments have been done with collapsing an orange, how the earth, when it cooled, it collapsed and it could form a tetrahedral shape. Therefore, the tetrahedral hypothesis was in line with the concepts of a cooling and a shrinking earth. The shrinking attributed to a smaller cooling nucleus on which the already cooled crust had adjusted itself. The tetrahedral hypothesis proponents felt that the sphere, which was the initial form, the aggregate matter collapsed into a tetrahedron while cooling and accommodating around a shrinking nucleus. This once more one goes back to the orange peel and the orange center concept, that as the center of the orange gets smaller, the peel tries to adjust itself to the center, and in that manner there are bulges and there are depressions in the orange peel. So, in the same way, since the Earth's center was shrinking, the outer part of the Earth or the crust was collapsing into a tetrahedral form, the spines being the continents and the depressions being the oceans. The proponents proved at this point by accounting for the tetrahedral form taken by the Earth as it is seen today. Criticism of this hypothesis. A major drawback of the tetrahedral Earth theory, according to critics, was that the spherical Earth may deform to a tetrahedron in cooling, but in time it would revert back to its spherical state, as it would have a tendency towards attaining equilibrium. Many scientists attempted to explain the irregularities of the Earth's surface. Some thought that the continents were major upfolded masses and the ocean basins as downfolds, but the sheer size of the Earth's major relief forms was such that there was no chance of them forming due to folding. In the beginning of the 20th century, Sir J. Jeans put forward his observation regarding a pear-shaped Earth, the pear-shaped remaining after the moon was torn out of the Earth. This was also a very popular theory and hypothesis. In this, he tried to explain the dominant northern hemisphere and the southern ocean hemisphere. I hope I have been able to convey the different theories of the Earth system, how the planets were formed, and in the process, how the Earth took a tetrahedral form as we see today. Thank you.